Welcome back to Maths Mastery. In this lesson today, we'll be looking at how to multiply and divide fractions. So in our last lesson, we looked at how to add and subtract fractions with the same denominator and how to add and subtract fractions with different denominators. So in the first case, when they have the same denominator, we just either add or subtract the numerators of both fractions if they have the same denominator. And in the case where the denominators were different, we'd have to find a lowest common multiple or denominator between each of the denominators of each fraction. And with that lowest common multiple or lowest common denominator, we convert each fraction into ones that have the same denominator, and then the steps are pretty much the same when we add or subtract fractions with the same denominator. So in today's lesson, we will be learning how to multiply and divide fractions, and also with understanding how we can visually represent multiplying and dividing fractions, because sometimes pupils or students may know how to perform the sum, but you may not know how to visually understand what it means to multiply and divide fractions. So you may be watching this video and you may think, oh, I can do that easily, but understanding how it is visually represented can help to better aid your understanding and refine your knowledge in multiplying and dividing fractions. So we will look at how to perform the sum, just perform multiplying and dividing of fractions, but also we're going to look at how it can visually be represented as well. So multiplying fractions is fairly straightforward. So if we have two or more fractions together, we just multiply the numerators and then their denominators. So as an example, we have a half multiplied by 1/4 or quarter. So all we do is we multiply the numerators and denominators together. So what that means is we would do 1 times 1, which is 1 times 1 over 2 times 4, because we're multiplying the numerators, which are both 1, together, and the denominators 2 and 4 together. So our answer is 1/8. 1 times 1 is 1, 2 times 4 is 8. And as a second example, we have 2/3 times 3/4. So the same rule applies. 2 times 3 over 3 times 4. So 2 and 3 are our numerators, we multiply them. 3 and 4 are our denominators, we multiply them together. So we would have 2 times 3 is 6, and 3 times 4 is 12. Now, in the case where we have to divide fractions, we flip the second fraction and multiply the two fractions together. So when we say flip, what we mean is the second fraction, the numerator and denominator swap positions. So for example, if we had a half, if we flip the fraction, each number, the roles become reversed. So a half then will become 2 over 1, because 2 becomes our numerator and 1 becomes our denominator. So our sum becomes 1 times 2 over 7 times 1. So if we were to rewrite the division problem, so we flip the second fraction and multiply the two fractions together. So it will become 2 over 1. So 2 becomes our numerator, 1 becomes our denominator, which is what the sum we have here. So 1 times 2 is 2, and 7 times 1 is 7. So our answer is 2 over 7. Another problem here is a half divided by 2 over 3, or 2/3. So our sum, if we apply the rule of flipping the second fraction, not divide, it should be times, becomes 3 over 2, because 3, when we flip the second fraction, 3 is our numerator and 2 is our denominator. So it then becomes a half times 3 over 2. So our numerators 1 and 3 are multiplied, our denominators are both 2, we multiply them. So 1 times 3 is 3, and 2 times 2 is 4. So a half divided by 2/3 is equal to 3 over 4, or 3/4. Now, the interesting part is looking at how can we actually visually represent multiplication and division of fractions. And I think the visual idea is more interesting, because you can really see how you are actually, what it means to multiply and divide fractions, rather than just understanding how to perform the calculation. Here you can visually see what is happening when we multiply or divide two fractions. So if we look at the previous sums, but in a visual form, this is a half times a quarter. So when we want to visually represent this sum, we have a half here and a quarter over here. So what we do is we represent 1/2 first of all. The first fraction we show is a half. So 1/2 means we split the square into 2 and we shade one of the pieces, which shows 1/2. And then we represent our second fraction, which is a quarter. So we split our square into 4 pieces. So that's 1, 2, 3, 4. And then we shade one of those pieces to show a quarter, or 1 over 4. So what we're now looking for, so we've shaded a half and we've shaded a quarter. So what we're looking for is to find where the shading overlaps, i.e. where is there both a blue and purple shading. And you can see it's over here because this piece, both the purple and the blue are shaded. So that shows us the multiplication of both a half and a quarter. So we ask ourselves, okay, how many pieces have both a blue and purple shading? Which is only one. And it's out of how many pieces altogether? There's 1, 2, 3, 4, 5, 6, 7, 8. So our answer becomes 1/8. So we're looking for which pieces in our diagram have both a blue and purple shading, where they both overlap. And there was only one out of how many pieces? 8 of the pieces. So 1 out of 8 pieces altogether. So our answer is 1/8, which is the same thing if you were just to work out this problem just by calculating it. So you do 1 times 1 is 1, and 2 times 2 is 2 times 4, sorry, is 8. So it's the same answer we got from, and the same answer from our previous slides as well. And in a similar idea, if we wanted to show this sum, so this was on the previous slide, 2/3 times 3/4 or 3/4. We first represent 2/3. So we split our square into 3 pieces, and we shade in 2 of those pieces to represent 2/3. So this is 2/3 because there's 2 pieces shaded and it's split, divided into 3. And 3/4, we split the square into 4 horizontally, no, vertically, sorry, and we shade 3 of the pieces. Okay, so with the same idea, we're now looking for, to represent the multiplication of 2/3 and 3/4, we're looking for how many pieces have both a purple and blue shading, so i.e. where they both overlap. So there's 1, 2, so 1, 2, 3, 4, 5, 6. There's 6 pieces that have an overlap, i.e. they both have a purple and blue shading. So our numerator of our answer would be 6 out of how many pieces altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will be 6/12 is our final answer. And you can check by seeing that 2 times 3 is 6 and 3 times 4 is 12. And of course, you can simplify this answer to a half, because 6 divided by 6 is 1 and 12 divided by 6 is 2.